Hi, my name is Munir Karpouzi, and today we'll be performing a Grignard reaction with an aldehyde. So to start this reaction, we first draw our aldehyde molecules. So it's a C bonded to an H and an R with a double bond to an O. It's our aldehyde. And our reagent for this reaction, our Grignard reagent, is an R prime with a magnesium bonded to an X. And I use the R prime so you could differentiate that they could be different sizes between the one on the aldehyde and the one on the reagent. We get this reagent from an alkyl halide mixed with a magnesium and ether group. We have an R prime connected to an X, connected to a magnesium and ether. When we look at the R prime, we can look at it as kind of a group of lone pairs, even though it's not, but we can because it resembles an alkali chain with a lone pair, so the electrons are like the lone pair, and they usually attack delta plus molecules. So when we assign charges, we can assign, so we draw the C connected to the H, connected to an R, double bonded to an O. So we determine that the oxygen is a delta negative group. It's electronegative. And then we assign the carbon a delta positive because the delta plus is connected to the electronegative atom. So we're going to draw the aldehyde again to C to the O, H, and the R. And then the reagent will attack the carbon and force the C to push the double bond between the C and the O to assign a lone pair to the oxygen rather than the carbon. Because we do that because the carbon would violate the octet rule if we leave the lone pairs in the carbon, so we move it to the oxygen. And now the oxygen, so we'll still have the R connected to C, connected to an H, now connected to an R prime, and a single bond to an O with 3 lone pairs and a negative charge. When we look at the positive charge, that's on the magnesium plus the X. But since that's not attached to the R prime group, we don't worry about that, so the positive goes away. And now we will have to mix with an aqueous acid. It could be any acid like HCl. I'm going to use H3O+, just so we could give an H+ to attach to the oxygen. So we'll have an R attached to the C, connected to an H, connected to the R prime, with a single bond to the O, but now we'll add an H, and we'll get this H from the aqueous acid over here. And then this will be our final product. And the final product is a secondary alcohol. And that's what we end up with producing. And we notice this because the Grignard reagent attacks the carbonyl carbon in the middle, and it's a deprotonized secondary alcohol or an O negative with the delta negative charge. So then we would mix it with the aqueous acid and produce a secondary alcohol as our final product. So thank you.